Hey everyone, welcome back to the channel. Today we will be solving a group anagram problem in the LeetCode using Kotlin. Let's begin by understanding the problem statement. The problem asks us to group anagrams from the given list of words, and we can return the answer in any order. Anagrams are words or phrases formed by rearranging the letters of another word, typically using all the original letters exactly once. We have already solved the easy variation of such a problem before. You can click on the I button at the top right to go through that. Let's take a look at the first example. Here we can see that 8, T and 8 are anagrams of each other, so we will group them together. Similarly, net and 10 are anagram of each other, and bet will be the single item in the list. In the second one, if we have an empty array, then we will return the same. And in the last, there is only one element in the array, so we will return that. In the easy variation, to figure out whether two strings are anagrams of each other, we created a hash map that tracked the count of the letters in each string, where the key was the letter in the string and the value was the count. Now we have to extend our concept that we learned in that problem. In this problem, we have to group all the strings that are anagrams of each other. So we may think of having some logic for choosing the key so that we can group the anagrams. As we did for the valid anagram problem, we can represent each word in the input as a 26-sized array, since in the problem we are given that all strings consist of lowercase English letters. Each position denotes the count of the letter in the string. So 0 will keep track of the letter A, 1 will keep track of letter B, and so on. To convert the letter A to denote the position 0, we will subtract the input letter with the ASCII value of A. So if we subtract C from A, we will get 2, and in the array, C will be at position 2. Using this method, we will represent all the strings in the input like this. As we can see, the strings that are anagram of each other will have the same array. So in the hash map, we can use string as a key and convert the array into string using join to string method. Now the problem becomes very easy as we have figured out a way to selecting the key for the hash map. Now we can loop through the input list and generate a key for the current string. If the key does not exist in the hash map, we will create a new list as a value and add the current string to it. If the key already exists, then we will append it to the list. At the end, our hash map will look like this, where the strings that are anagram of each other will be grouped together. Let us quickly go through the code. We will first create our function which generates a key for the input string. Using the ASCII value, we will create our array that tracks the count of the letters, and in the end, we will convert the array to string and return it. In the main function, we will first initialize our hash map, where the key is the string that we get from the function that we created earlier, and the value will be the list of strings that are anagram of each other. Now we'll look through the input list and generate a key for the current string. If the key already exists, then we will add it to the list. Else, we will create a new mutable list and initialize it with the s, that is the current string. At the end of the loop, we will return the hashmap values as list. To determine the time complexity of the program, we can see that first, we iterate through each string in the input array, which has n strings. And for each string, we generate a key using the generateKey function, which takes big O of m time, where m is the length of the string. Therefore, the overall time complexity will be big O of n times m. We use a hash map to store the anagram groups, and in the worst case, each string is unique and gets its own entry in the hash map. This results in the space complexity of big O of n for the hash map. For each entry in the hash map, we store a key that has a length of 26. So it takes big O of 26 or big O of 1, that is constant space. So the total space complexity of the problem will be big O of n. That is it for today. If you learned something, please leave a like and subscribe to the channel. Thank you and have a nice day.